The last task that you're going to do with this system is to measure out the wave function for a couple of different resonant modes. What does the map of the standing wave amplitude versus position actually look like inside of our sound tube? Well, our system is well designed to investigate this. We can set it up, tune to a resonance frequency, as we just did, and then it will show us the amplitude. Okay? Then we can move the microphone to different points and look at the amplitude as a function of position. So I've just done that in a few different places. Do you notice something interesting? Look at where the peak is and where one of the troughs is now. Then I'll move the microphone back to the beginning point. There's a lot of more noise while we're moving it, but it settles away. Did you notice that the signal inverted? That's because in between those 2 points, there's a node. Where was it? Right around here. Yes. So we're going to map out a standing wave pattern, and then we'll be able to see where the nodes and antinodes are. Now we could do this simply by having you move the microphone to a different position, record the amplitude, go to the next position, and so on. But that's kind of tedious. So we can partially automate that using a LabVIEW program, and so that's what we'll do. The first step in using this program is to tune the system to a resonance, much as we've done here. Then we have to stop data collection, and then bring up this program called Wave, or Wave 3. And when we run this, it will sort of semi-automate the process of collecting the data. It won't move the microphone for us, but what it will do is that each time we move the microphone and hit record, it'll take a measurement and then add it to a graph and keep track of all of that for us. So it takes all of the overhead out. When we run this program, it will ask us first where we'd like to save the data and what file name we'd like to give it. So I'll give it a test file name and put it somewhere. But then we're ready to go. We should set the initial position. In this case, let's say 5 centimeters. We can use whatever units we want, of course. We set the interval. Let's set it to, let's say, 10 units, 10 centimeters. And then we set the phase. Remember the phase from the previous video? So the best phase was something like 340 degrees. It doesn't matter if you get the phase exactly right, but it would matter if you got it exactly wrong, meaning the correct answer plus or minus 90 degrees. Okay, once we're ready, we press start. And then once the microphone is where we want, we should make sure there's no noise and nobody's touching the system. And then we can click on read mic, and we'll do a sound measurement, like so. Okay, after that, we move to the next position. Make sure it's quiet. Move to the next position. Move to the next position. Move to the next position and take a point. Move to the next position, and so on, all the way down the length of the tube. Once we've gone across the entire range of the tube, from the point closest to the speaker to the point furthest away, then we press stop, and when we press stop, it saves the data. Okay? Very good. So that's how this last part works. And you should expect to see a graph of amplitude versus position for the wave function of the standing wave. And from that, you can see where the nodes and antinodes are. All right, let's stop here.